Hello everyone, my name is Timothy Lee Grant and welcome back to Leetcoding. So we are continuing to try to get a wide breadth of topics on the Leetcoding sphere of things, trying to have it seep into our subconscious. So every single day doing a LeetCode, trying to improve, trying to move forward, become a better software engineer, and people are gonna get all uppity about that. They're gonna say Leetcode isn't software engineering. We're doing the projects too. We do project videos. We do JavaScript, Java, machine learning, software engineering bundles, all of those videos on this channel. But we also do Leetcoding. So let's get going. Let's do a Leetcode. All right. So which topic should we do? What are you guys thinking? How about a binary search? Do you want to do a binary search? All right, let's do one. Let's do it. So, if you guys remember, I was intensely doing LeetCode and I was doing uh, depth first search, I think, or something like that. And then I moved on to binary search, and so I was doing binary search, but then I decided to, lower the intensity a little bit and start to look at a wide array of different problems. So I guess now we are returning back to binary search, and I just want to do an easy one. Let's pick an easy one. Valid perfect square. Okay, so let's see if this is a reasonable one. Let's take a sip of water. All right. So, 367. Valid perfect square. Given a positive integer, return true if num is a perfect square, or false otherwise. Okay, so we're given a number, and we want to say if it is or is not a perfect square. Okay? Now, a perfect square is an integer that is the square of an integer. In other words, it is the product of some integer with itself. Okay, so uh, like 2, or sorry, like 4 would be a perfect square because it is 2 times itself. So 2 times 2. So 2 squared, right? 4. There we go. So 4 is a perfect square. So it can be squared or it can be square rooted. Okay? You must not use any built-in. Oh, darn. So we can't use. you know, I was thinking just doing a square root function and then seeing if there was any remainder. And I was like, okay, well, hold on. I think I can just do it like that. Bam! Gotcha! Nope! Rejected. Okay, so we have to think of a different method. All right. Okay, so 16 is going to be true because it is 4 and 4, right? Here, 4 times 4 equals 16. Yep, so there we go. 14 is false because, okay, 3 points, blah, 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 equals 14. So it's not an integer. Okay, so what I'm thinking is I know that I'm going to be searching. Okay, so I have here, I know that I'm going to be searching between, like, let's say that num is equal to 16. Okay, so I know that I'm going to be searching between 1, 2, 3, dot, 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 all the way up to 15, 16, right? And so if there is a perfect square of this 16, it's going to be one of these numbers, right? It's either going to be 1 times 1. Does 1 times 1 equal 16? No, it doesn't. And let me just add 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, I'm just going to write all of them. So if the number is 16, I know that it's going to be one of these numbers times itself is going to equal 16. Okay, so does 1 times 1 equal 16? No, not really. Does 2 times 2 equal 16? No, not really. Does 3 times 3 equal 16? No. Does 4 times 4 equal 16? Yep. So, there. We found a number that satisfies that condition. We can wash our hands, return true, and say, yes, 16 is a perfect square. That's what they're calling it. Okay, so one solution would be just to start here at the beginning and go here, then here, then here, then here, and then get it. Now, what would be the time complexity of that? It would be O of n, because we could possibly search through all of these. Now, obviously, based on the problem, if you think about it, it's going to be the square root of this number here, which is going to tend towards the lower end of things. But still, theoretically, it's O of n, right? So the way that I'm thinking about doing it is, maybe it's because I was primed with this binary search because we specifically chose it from this category, possibly. But what I'm going to do is do a binary search. So I'm going to look here, I'm going to look at this 10. So I'm going to go to the middle, and I'm going to say 10. Is this number greater, or so 10 times 10, is that greater than 16, or is it less than 16? So 10 times 10 is 100, so that's greater than 16. So I know that I need to search through this section, okay? So then I take the middle of this section, and I look at this 5, and I say 5 times 5. Okay, that's 25. All right, that's bigger than 16, so I know that 5 is out. All right, so now I know that I need something smaller, okay? So now I'm looking here, and then I'm going to choose the middle point, which let's just say it's 2, okay? So I look at 2, and I say 2 times 2, 4. Well, 4 is less than 16, so I need something bigger. So I know that it's not going to be 1, and I know that it's not going to be 2, so it's either going to be 3 or 4, or it doesn't exist, right? Because we already tried 5, and we know that 5 is too big. So we needed something smaller than 5, and we need something larger than 2. So it's either 3 or it's 4. So now what we do is we take the midpoint. So let's take this 3, okay? There's only 2 elements, and it's going to default to the lower one. So 3. 3 times 3, 9. Is that bigger or smaller? That's smaller than 16. So we say, okay, 3 is out. Now we're going to move it to this element. And now we take the midpoint of this singular element, which is 4, and we say, is this equal, 4 times 4, is that equal to 16? Yes, it is. So we can return true. So we're just doing that binary search and trying to whittle down our available options. Now let's think about let's think if this wasn't 16, but it was like 17, right? I get to 4, and 4 times 4 is 16, so it's less than the number, which is 17, right? Because I said that we're looking for 17. Okay, well now we try to take the larger of 4, but we're at the end. So that's where we can say, all right, false. We can return false. So let's start coding this up. So left equals 0. So we're just looking at the index. So it's the 0th index. Okay. Right equals length of nums. Okay. All right. So this is the index corresponding to the end of our list. Okay. Now, what I want to do is just create this list that has all of these numbers in it. Okay, so for, let's see, how do we do this? My list equals, and then x, for x in range, and then length of nums. Okay, so this is going to give me how many elements are in. No, num is just a number. Hold on, num is a number, it's not an array. So I just need to go is nums and not length, but nums. So I want to, in this case, num is going to be 16, right? Num equals 16, and I want to create a list starting at, and I guess this actually would start at 0. So we would have 0, 1, 2, 3, 4, 5, all the way to 16. And this right is going to be equal to 16, which this is the actual 17th index, but because we start at 0, it's indexing here, right? Number 16 or 17 indexes here. Okay, so do I actually need to do nums plus 1? Because nums is 16, and I have a 0 right here. So yeah, I need to do index 17 to get here. So now I want to create this list here. So I'm going to go for x in range nums plus 1, because the start is going to be implicit at 0, okay? And it's going to go all the way to this nums, but it's non-inclusive, so we need to go to one more. So it's going to be 16, but it doesn't include 16. So we want to include 16, we put that plus 1 there. So now it's to 17, and it doesn't include 17. And then this syntax here with the brackets just means put it as a list, and each iteration we're taking this x and we're, see here, putting that x into the list. Okay, so now we have a list just like this. So I'm going to actually call this my list equals, right? So it's just like that. Now what do we want to do? All right, so while left is less than right, and I also want equal to, because remember, if left and right are both equal to 4, like we did in our initial example, I do want to check this case. If left is equal to this index and right is also equal to this index, we need to check it, okay? So how do we do this? Now we find the midpoint. So mid is equal to what? It is equal to left plus right, and then integer division 2. So we're taking 0 and then plus 16, okay, and then dividing it by 2. All right, so now what do we want to do with this? We found the midpoint, so we're here at 8, okay. We want to see if this midpoint times itself is going to be equal to the 16. So I'm going to say, and now that I'm actually thinking about it, I don't even know that I need a list, really, because left is an index and right is an index, but the index kind of just corresponds to the number itself. So I don't need to waste, this wastes a lot of time and space. I don't need this. I don't need that. So we have mid, okay? So now if mid times mid is greater than num, okay, num, then what do we do? So we're looking at this like 8, and we go 8 times 8 is 64. So 64 is way larger than our target 16. So we know that we need something smaller. So we're going to be checking here any of these numbers, because it's going to, these numbers are the only values that can give us something smaller. So we want to change the right bound to be not here over at 16, but now here at this 7, right? And we don't need to include this 8 because we've already seen this 8 and we know that it's invalid. So what I can do is write equals mid minus 1. So mid currently is this 8, and we're going to say, all right, now you are 7. So here's the lower bound, or upper bound, sorry. And our lower bound is still this 0. All right, so now, else if, nope, that's not correct Python, elif mid times mid is less than num. Okay, what about this case? That means that it's like this 1 times 1. Well, 1 times 1 is 1. And we're trying to get to 16. So I don't want 0 times 0. I don't need to check that. I don't need to and this 1 times 1 we've just found to be incorrect. So we know that it's going to be somewhere from this 2 all the way up to this 7. Okay? So we don't need to check the lower. We need to change the lower bound to be 1 higher than the value that we just currently determined was less than the square of our target. Okay, so now we change left equals mid plus 1. And the reason we're doing plus 1 is, in this case, we did 1 times 1, which is equal to 1, which is less than 16. So we know that we need something here, which this bound is what? We currently mid is at 1. By the way, according to our algorithm, it's obviously we would check something from here, then go in the middle, and it's like 3. So actually, let me use that as an example. So we find the midpoint, which is 3. 3 times 3 is 9. So mid is 3. 3 times 3 is less than 16. So do we need to check this 2 or this 1 or this 0? No. And we know that 3 doesn't work either. So currently mid is 3. So we need to check this 1 higher than this 3. This now is our lower bound, and this is still our upper bound. So we do left equals mid plus 1. Okay? And then elif mid times mid is equal to num. Then we return true. Okay? So now we're going to keep going. Each time we're going to start with a big list, and then we're going to whittle it down. We're going to come down and we say, okay, we don't need to check any of these top ones. We're changing our right bound here. Then our left bound is still here. Then we change our left bound and we say, okay, our left bound is here. Then we move again and we say, all right, well, now I can determine here's our area. And then I say, here's our area. And then all of a sudden our left and right are equal to something. Okay? Are to the same thing, right? This 5. But now 5 times 5 is 25, which is larger than 16. So we're going to adjust our right bound this way. And now left is actually bigger than right. So this no longer is correct. This no longer triggers. And so what we can say is if we get out of this while loop, we know that we checked all of the valid possible solutions to this problem, and none of the numbers in this list actually came up to be a valid square of this num. So we can just return false. Okay, let's submit this, see if it likes it, and there we go. All right, so again, I really like this because it does kind of prove that, you know, I was really struggling with binary search and I was having a really difficult time. You can go watch my previous videos and I was just like beating myself up about not being able to solve binary search. And I know you guys can say like, oh, well, this was an easy problem. You picked an easy problem. Of course you're going to be able to solve it. But the point is, in the past, I was really struggling to get this conceptually. I couldn't understand how you manipulate left, right, and is it inclusive? Is it not inclusive? Is this equal to? Is it not? Like, is it like this or is it like this? And trying to figure out like how it's whittling these down, it just threw my mind. I don't know why. Again, and you can go watch those videos. In my videos, I say like, man, am I an idiot? I've never heard of someone say like, oh, binary search is so difficult, but it felt difficult to me. And so I was freaking myself out, but I took some time away. And I don't mean I stopped doing Leetcode. I mean, I lowered the intensity. I no longer was like, I have to solve this. I will solve it. I have to do it. I have to like hardcore study Leetcode. I took the intensity down. I said, I'm going to give myself a little bit of space on this. I'm going to continue doing Leetcode every single day. I'm going to try to get a wide variety of different problems. I'm not going to stress out about it. And this was my first time doing a binary search since I initially studied it. And now I look at this and I just feel like, yeah, okay, it makes perfect sense to me. So again, I really feel that this is valid proof that getting exposure to Leetcode and these types of problems is immensely beneficial and can help you even if you don't feel like you've made progress. So just keep doing Leetcode, keep getting that exposure and putting it into your subconscious. And yeah, so I mean, thank you guys for watching this video. I'm going to continue to do Leetcode. If you like these videos, it would be amazing if you would subscribe. That would be awesome. I broke 500 subscribers now. I have like, what's my actual number? Let me check it. I have right now 524. Can you guys see it? 524 subscribers. Nice. Cool. So thank you to everyone who subscribed, and I hope you guys have a wonderful rest of the day, and goodbye.